right, the hyperbola. Locate a hyperbola's vertices, write equations of hyperbolas, graph center at the origin, graph hyperbolas not centered at the origin. We're going to skip this just because of time, and there's only so much we can figure out in the last few weeks here, right? All right. Um, Definition of a hyperbola. Hyperbola is the set of points in a plane, the difference of whose distances from the two fixed points are called the foci, is constant. Remember, the ellipse was the sum of the distances, and the hyperbola is going to be the differences whose distances are a fixed point. All right. Um, Standard form of the equation. Um, Notice that again we have some consistencies, only in this case notice what changes. It wasn't the a squared that changed, it's the y squared. It's what's positive and what's negative now, is what's determining the a and the b. It isn't the larger number, so be clear on that. Notice that to find c, we're using the Pythagorean theorem for these. All right, so we're going to jump right into this stuff, and they said find the vertices and locate the foci for each of the following hyperbola. Okay, now first of all, what is a hyperbola? Hyperbola are two parabolas put together uh, in essence, okay? We know now, because this is uh, a positive x, that a is going to be 5, b is going to be 4, c is equal to the square root of 25 plus 16, or square root of 41. All right, we know that the center is at 0, 0 because there is no h and k. We then know that um, the vertices of these are going to be, um, we're going to add the 5 to 0, 0. And I should say that because the x is positive, this is a horizontal hyperbola, so therefore the vertices are going to go plus or minus 5 comma 0. Um, the foci, that's the vertices, the foci are going to be plus or minus the square root of 41 comma 0. Square root of 41 is going to be a little bit bigger than 6. You're going to want to graph, we'll call it the covertices. They aren't really covertices, but you're going to want to graph the covertices. That's going to be 0 comma plus or minus 4. Um, our job here was to find the vertices and the foci. So here we go. The next one, part B, says that we got a y squared, so we know this is a vertical hyperbola. We know a is 25, I'm sorry, is 5. B is 4 still, so C is going to be the square root of 41. The difference now, again, we got the center is still at 0, 0. The vertex now is going to be 0 comma plus or minus 5. The foci are going to be 0 comma plus or minus square root of 41. That's basically the quick introduction to this. Let's take a closer look. Find the standard form of the equation of hyperbola with foci at, and again, you guys, anytime they give you stuff like this, go ahead and sketch a picture and see what it looks like. The foci are at plus or minus 5, right? So that's going to be here and here. That means this is going to be a vertical ellipse. That means this is going to be y squared over something minus x squared over something equals 1. The vertices are going to be plus or minus 3 there. That's your sketch. We know that A then is 3. B we got to find out. C we know is 5. So therefore, remember we have A squared plus B squared equals C squared. So if we plug those in, 9 plus B squared equals 25. We get B squared equals 16, or B has to equal 4. That means we're going to go 9 and 16. There's our equation in standard form. Pretty straightforward. The patterns are similar to that of an ellipse. You need to get a couple of things straight. We're not looking at the largest number. Um, we're looking to see if it's horizontal or vertical. Okay, so a little more in depth of what we're looking at. We're looking at hyperbola. Notice the equation. X squared is positive and it's horizontal. Um, we're not going to get into writing equations of asymptotes, although it's not a bad thing to pay attention to the fact that we have equations for that. What we are going to get into is we know that we got vertices here. We're going to call these covertices, just for lack of a better term, so that we can sketch this box. Okay, when you draw that box, notice the diagonals go through the vertices of the box. The hyperbola then is drawn so that it goes from the vertex and approaches the asymptotes. Okay, keep that fairly simple. Same thing is true for the vertical hyperbola. Again, more of the same formulas. They're going to suggest that we locate the vertices, use dashed lines to draw the rectangle centered at the origin with sides parallel to the axes. That way we can draw the asymptotes, right? Draw the asymptotes. And then lastly, draw the two branches of the hyperbola by starting at each vertex and approaching the asymptotes. So let's see what that looks like. All right, it's an x squared, so this is going to be a horizontal hyperbola. We know that A is 6, we know B is 3, we know C is going to be the square root of 36 plus 9, which is square root of 45. We know that's almost 7, so approximately, what do you want to call it, 6.7 or something to that effect. That reduces to 3 root 5. This is the number that's going to be helpful for graphing. And that's what they're asking us to do, graph and locate the foci. All right, because this is horizontal, we got a center at 0, 0. We got vertices at plus or minus 6 here and here. We got foci at 6.7 here and here. We have the, again, lack of a better term, co-vertices here and here. That allows me to sketch this box here and identify the vertices there, right? With that box, that allows me now to go ahead and do something like this. And again, you may have to use, if you use a ruler, it'd be a whole lot easier, I think. I missed it. I'm going to adjust that in a second. Um, I missed that one too. And now, again, notice you start at the vertex and this approaches the asymptote. Vertex approach the asymptote. Should not cross the asymptote. There's your hyperbola. That's pretty straightforward for both vertical and horizontal. Okay, remember these things are supposed to be equal to 1, so I need to divide by 4 to put this in a form, in the standard form that I like. So this becomes y squared over 4 minus x squared over 1 equals 1. Tells me my a value is 2. I probably should stop this. Why don't you guys go ahead and finish this, see if you can, and I'll get back to you. All right. So really isn't that bad if you can identify A, B, and C. I didn't draw my box because I could easily see where the vertices of the box are, and as you go, you can probably get away with that also. All right. So what happens when this moves away from the origin? You introduce your H's and K's, but the process is still the same. Let's take a look at this problem here. We know that this is going to be a horizontal hyperbola. A is 2, B is 1, C is going to be the square root of 5, and I'll let you do the calculations on that. Notice that we have a center. The center now is at 3, 1. Okay, that's interesting. So that moves everything over here, 3, 1. That's my center. Since this is horizontal, then my vertices go 2 to the right, 2 to the left. Vertices are going to be 3 plus or minus 2 comma 1. Foci are going to be 3 plus or minus the square root of 5 comma 1. We know from here we're going to go up and down 1, so we go there, there. The corners of my box are going to be here, here. Shoot, should have been here and here. I missed that, didn't I? That should have gone here. The foci are going to be a little bit bigger than 2, right? Square root of 5 is just little bit bigger than 2. So you can put it right out there like so. You don't need exact, it's a representation. Let's finish this up. So notice it really isn't any different than what we had done before. I'm not going to worry about the equations of the asymptotes. I won't even ask that on a test. Just need you to be able to identify vertices, foci, and maybe a graph. All right, this last problem will be extra credit. I will work it and show it. So if you're not worried about it, great. Otherwise, extra points, right? All right, just a quick rundown. Obviously, we had to complete the square. Notice that when I multiply by negative 9, it became minus 225 here, which made this negative, which switched the x's and y's, right? It switched those. Just pay attention to where your h and k go. Your h is over here, your k now is over here. You got your center, your vertices, your foci, and your graph. Good luck. Have fun.